The energy landscape is evolving rapidly with emerging technologies. It's a complex and decentralized network where we need to pay attention to its management because the challenges are huge and so are the opportunities. Energy management has a key role in the energy transition, together with energy storage, because it allows us to work around one of the biggest challenges with renewable energy, its intermittency. We used to produce electricity and heat whenever we needed it, and energy networks were built according to this fact. But renewable energy like solar and wind is weather dependent, and this irregularity leads to complex challenges like ensuring stable power, especially in periods of low production. Despite the challenges associated with intermittency, investment in renewable energy remains essential to reduce carbon emissions and promote long-term sustainability. So if we want this to be reliable, we must rethink the way energy management is working. We must consider shifting our energy needs to match them with the availability of renewables. In parallel, advances in storage technologies such as batteries and hydrogen are crucial to mitigate the impact of that renewable energy intermittency. It will be an important step to be less dependent on fossil fuels, but not the almighty solution, as we always must deal with some energy loss and durability problems. However, achieving a massive, cheap and efficient solution remains a significant challenge. So, we need to combine storage and balance to develop that long-term sustainability. As you see, the journey of energy is complex and full of challenges. We also need to consider that energy decarbonation leads to more electricity production and changing consumption patterns. It's even more challenging if you consider that first energy networks were centralized, meaning just a few big power plants surrounded by many consumers. But the rise and the need for renewable energies changed it radically. Since then, the energy landscape has been decentralized. Many smaller energy producing units like solar panels and wind turbines affect the way that energy travels over the network. Energy producers, energy consumers, and energy storage systems can appear anywhere in the field. Indeed, concepts like smart grids can help to minimize the effects of renewable energy intermittency and decentralized energy flows, because those grids leverage digital communication, automation, and real-time monitoring to optimize the flow of energy, to respond to changes in demand on a steady basis. Other concepts can be introduced in addition to those smart grids. Microgrids, for example, which refers to a small-scaled, localized energy system that can operate independently or in conjunction with the main electrical grid to generate, distribute, and manage electricity in a specific geographic area or for a particular community. Now that we've covered those points, you've got a clearer picture of the issues with energy network and storage solutions. To understand energy better, how it powers our homes, and ways we can make it better, just check out the documentation. It's like a user-friendly guide with 4 chapters that break things down for you. The first 2 chapters explain the generation and distribution of electricity actually and globally. As we said, storage of energy will be an important brick to work around intermittency. Some concepts and ways to do it will be explained in chapter 3. Another important form of energy is heat, and you will have a closer look at its network and storage, also explained in this 3rd chapter. Then comes the final chapter where all previously discussed topics come together: the management of energy flows and how to get the most out of it. But even if the management and the storage of energy are key points, the removal of fossil fuels will not be possible without a radical change of our energy consumption patterns. We will do that in the next module.